So problem 7.3. Check that the following functions satisfy the specified differential equations where c, c1, c2 are constants. Okay, so what's the differential equation? We haven't seen this term before, right? So we have seen equations such like, let's say, e to the x minus x plus 1 equals 0, right? And so the unknown here is this value x. Okay, so the solution of this equation is a value of x that fulfills this identity, right? Well, differential equations are equations where the unknown is the function. Okay, so a function like this: x times f prime plus f equals 0. Okay, here what we don't know is which function f satisfies this identity. Okay, and they're called differential equations because they involve derivatives. Okay, you can have the second derivative, whatever. Okay, solving a differential equation, that is finding the function that fulfills this this equation, it's another subject on itself, and you will learn how to do it later in your degree, but this is outside the scope of a calculus 1 course. Okay, but so this is not what we need to do here to solve the equation. Okay, what we have to do is we're given a proposed solution, a function that they tell us is satisfying this equation, and we need to check. Okay, it's like saying that, for instance, x squared plus 2 equals 0, okay, or let's say x squared plus minus 4 equals 0, and I say x is 2, check that x equals 2 satisfies this equation. Okay, this is the same thing but with differential equations. Okay, so let's do all of them. The first one is, I have this differential equation: x times f prime plus f equals 0. Okay, and this is valid for all x, right? So, and then we have f is c divided by x. Okay, we can also write this like this. Okay, this is just a shorthand way. Okay, now in order to check that this function solves this equation, we need to compute its derivative. Okay, and the derivative of this is minus c divided by x squared, right? So if you multiply it by, this is x minus c divided by x squared plus c over x, which is the value of f. And so this is x and divided by x squared is x in the denominator, minus cx plus cx is 0. Okay, so this f checks and satisfies the equation. Okay, let's do part 2. F of x is x tangent of x, and the equation that it fulfills is x f prime minus f squared is x squared, right? So now we have that f prime, we need to compute f prime, is the derivative of x times the tangent plus x times the derivative of the tangent, which is 1 plus the tangent square of x, right? Well, if we want to substitute here, we have x times the derivative, so we have x times the tangent of x plus x squared plus x squared times the tangent squared of x. I have expanded this, minus f, which is x tangent of x, minus f squared, which is x squared tangent of x, right? And so now we have x tangent of x and x tangent of x cancel out, this cancel out, this cancel out. This is equal to x squared, which is what we wanted to check. Okay, so again, this f fulfills the differential equation. Now 3, f of x is c1 sine of 3x plus the c2 cosine of 3x satisfies this function. F second plus 9f equals 0. Now the derivative of this, we need to compute the second derivative here, right? This is 3 times c1 cosine of 3x minus 3 times c2 sine of 3x, and then the second derivative of x is minus 9c1 sine of 3x minus 9c2 cosine of 3x. So we substitute here, we have minus 9c1 sine of 3x minus 9c2 cosine of 3x plus 9c1 sine of 3x plus 9c2 cosine of 3x, which is equal to 0. Okay, because everything cancels out. So that checks again. Okay. Let's do part 4. F of x is c1 e to the 3x plus c2 e to the minus 3x, and it satisfies f prime minus 9f equals 0. Well, the first derivative of this is 3c1 is 3x minus 3c2 e to the minus 3x, and the second derivative is 9c1 e to the 3x plus 9c2 e to the minus 3x, and you see how this goes, right? 9c1 e 3x plus 9c2 e to the minus 3x minus 9c1 e to the 3x minus 9c2 e to the minus 3x equals 0, because this cancels out and this cancels out. Okay, so this checks. Let's do part 5. 5 is f of x is c1 e2x plus c2 e to the 5x. Let's compute the first derivative. Is 2c1 e to the x plus 5c2 e to the 5x. F second is 4c1 e to the 2x plus 25c2 e to the 5x. And so the equation is f prime minus 7f prime, sorry, f second minus 7f prime plus 10f equals 0. Well, we have 4c1 e2x plus 25 e to the 5x. Let's see, minus 7 times 14 c1 e to the 2x minus 35 e to the 5x, and then plus 10 c1 e to the 2x plus 10 e to the 5x, sorry, and then this is also multiplied by c2, c2, and c2. All of this and all of this cancel out and you get 0. So this checks again. And then the last one, f of x is the logarithm of c1 e to the x plus e to the minus x plus c2. So we need to compute the derivative and the second derivative. The derivative of this, let's see, the logarithm of this is divided 1 divided by c1 e to the x plus e to the minus x, and then in the numerator you have the derivative of this, c1 minus e to the minus x, and the derivative of this is 0. And then the second derivative of this is the square of the denominator, right? Now the derivative of this, which is again, right, times the numerator, sorry, the denominator, so this is squared, and then minus this, okay, c1 e to the x minus e to the minus x times the derivative of this, which is the same thing here, so this is squared. Okay, and so let's leave it here, I think. So we have f second plus f prime squared equals 1. Let's see, f second is this, c1 e to the x plus e to the minus x squared minus c1 e to the x minus e to the minus x squared, and then plus, and you will see that the denominator is the same in these two things, plus c1 e to the x minus e to the minus x squared, all of this divided by c1 e to the x plus e to the minus x squared, right? So now this, you get this and this are the same term, they cancel out, and then you get this divided by this, which is So this cancels out, and that's the end of the exercise.